Hello, I'm Ben Shirley with the Geography program with the Department of MSIT Coxie. Our project uses UAS drone orthophotography to model changes to UWG's campus. Unmanned aerial system drone photography has become an emerging industry in the geoscientific community and beyond. Emerging software that can analyze and model objects on the ground and display three-dimensional models of building and vegetation and map large areas of land are making drones more useful to a variety of industries such as agriculture and construction. Our presentation uses drone imagery collected from a commercially available drone, which was then processed by a software program known as Pix4D Mapper. And then the processed images were loaded into ArcMap and georeferenced to align the images, and then analyzed for year-to-year changes in the campus of the University of West Georgia's geography. From changes in topography to changes in tree cover and paved surface area, these types of data can be useful to multiple departments of the university system, from grounds and maintenance to new construction planning on campus. This presentation demonstrates the utility of drone photography and its application to commercial development, urban planning, infrastructure management, and natural resource conservation.
I'm Jessica Sinell, and I'm also with the Geography program, and I'm going to talk about the data collection and data analysis. In order to collect the images used to compile the campus-wide map, a DJI Phantom 4 Pro Unmanned Aerial System, more commonly known as a drone, was flown multiple times over a variety of locations to collect aerial photos of the UWG campus. Over 3,200 individual photos were collected in 11 total flights in several locations around campus. After the drone imagery was captured, the images were compiled into an imagery analysis program, Pix4D Mapper. Pix4D collects data from the drone, such as pitch, yaw, and roll, and pieces them together so they overlap. Once all of the overlaps have been calculated, the image is trimmed so it creates a uniform image of the entire campus. The longest portion of data analysis is the creation of a three-dimensional mosaic that provides the end user with a 3D model that can be viewed for terrain and elevation information. The final product was uploaded in ArcGIS Pro, an Esri program, which allows any user with a link to view the two-dimensional aerial photo map that was compiled from our images.
My name is David. I'm going to talk about measuring the accuracy using the National Geodetic Survey benchmark. The National Geodetic Survey is a branch of the National Oceanic and Atmospheric Administration that traces its roots to the early days of the United States Weather Bureau. They were responsible for surveying the interior and coastlines of the United States. They have placed objects known as benchmarks in the ground to mark permanent locations around the United States that can be used to calibrate surveying equipment. Our campus has a benchmark on the western edge of the Carrollton campus. This benchmark has GPS data available online that can be tested to determine how accurate GPS data in a survey matches these benchmarks. We analyze our image for accuracy by comparing the NAD83 benchmark data to the WGS84 data from our drone imagery and comparing how closely our image matches the coordinates. After plugging in the coordinates of the benchmark and plotting the point on our drone image, we used ArcGIS Pro to measure the distance to the benchmark in the aerial photo. The distance was 0.4 meters from the benchmark, so our image was about 15 inches off from the benchmark. This is because when the image is georeferenced or rectified, the image is stretched to match GPS coordinates, and the stretching can cause image distortion.
Hello, my name is Bryant Burrow. I'm with the Geography Department at the University of West Georgia. I'm going to talk about some changes between the two images. The 2020 and 2021 drone images provide an excellent contrast between the conditions required for drone orthophotography. The 2020 image was shot on an overcast day, while the 2021 image was shot on a sunny day. This presented the programs with a challenge and caused several errors that needed to be corrected to account for the shadows present during daylight conditions. Although this presented a challenge, the image quality is superb since the lighting conditions are much brighter. The 2020 image was generated with an older drone, and thus the resolution was only 2 inches per pixel, while the 2021 image used a 4K drone and provided a 1-inch pixel resolution. A close-up of the substation was provided in the bottom left corner of each map for clarity comparison. As you can see, this top image is from the 2020 image, and this bottom one is from the 2021. You can clearly see the defined corners of the brick enclosure for the substation. In fact, you can even see some gas pipelines, while in the upper image, it simply appears as a gray square. Some other changes in the 2020 and 2021 drone images include the construction of Watson Hall, which is located down here and here. In the 2020 image, you can see where the field has been cleared, but no construction has begun, while in the 2021 image, the structure is standing. Another difference is located in the upper right corner by the Foster Street parking lot. You can see the apartment complex behind the Foster Street lot is still under construction, while in the bottom image, it has been built. These kinds of images can be extremely useful to the Planning and Construction Services Department, as well as the Grounds Management Department, to assess the progress or needs for a particular construction project. As part of our research project, we also uploaded our image to the ArcGIS website so that it is publicly available for use to anyone interested in conducting a research project using aerial photography of the Carrollton campus. And this is the image that is available online, and you can download that image by going to the link below or scanning the QR code in the bottom right-hand side of our poster. Thank you.